Okay, so today I'm going to give a bit more help on how to draw a line graph because this one doesn't go through the origin, which makes it a little bit different. So first of all, before we start, we're going to label our axes because that's what a lot of the marks are for. So it tells me that I have to plot a graph of average friction, on the y-axis. And basically, if you remember, y's up. Okay, so y is the one that goes up, and we have to put average friction. So over here, I'm going to squeeze in. Sorry, I haven't left enough room. Average friction. And of course, you girls will be using a pencil. I'm just using the pen because I want you to be able to see what I'm doing. So that does say average friction. Okay, then it says against added weight on the x-axis. Now just remember, you have to include your unit. So that says average friction stroke N, capital N, because that is the unit of average friction. Now down here, I'm going to draw the label for my x-axis. So I'm going to write down added weight. And again, weight is measured in newtons. So I put /n. Now, I'm going to start with my x-axis and label the numbers. Now, my graph has to take up more than half the page, and my weight added has to go from 0 to 5. So if I, for example, went 0, and then I decided to put 1, 2, 3, 4, 5, well, that doesn't take up it takes up less than half of my graph paper, so that's not good. So let's try 2 squares per 1 unit. So 1, 2, 3, 4, 5, and that does take up more than half the paper, so that's much better. So this is my 1, 2, 3, 4, and 5. Okay, now I'm going to go to my y-axis. Now, I look at my smallest value and my biggest value, and I'm actually just going to start this one at 0. My biggest value for friction is 2, so I have to go from 0 up to 2 in even steps, and I have to take up more than half the page. So if, for example, I went 1 newton, 2 newtons, that wouldn't be more than half the page. If I did 2 squares, 1 newton, 2 newtons, that wouldn't be more than half the page, so that wouldn't be good either. So let's see what we can fit in. Maybe if we tried a quarter of a unit, so 0.25 newtons. So 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2. Okay, so that's the best option. So I don't have to label all the squares, but I'll just label most of them like this, right the whole way up to 2. Okay, now let's actually plot our points. So the first point that I have to plot is 0 on the x-axis, and then 0.7 on the y-axis. Okay, so let's first of all work out my values. So the x-axis is fine, those are nice numbers, but on the y-axis, let's have a little think about it. So 10 squares, so if I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 10 squares is equal to 0.5 newtons. So therefore 1 square, well, oh sorry, you can't see this, hang on. So 10 squares is equal to 0.5 newton. So to get from 10 to 1, I have divided by 10. So I'm going to do the same on the other side. So 1 square is equal to 0.05 newtons. Now that's really hard to work with. So let's think about it this way. 2 squares is double that, and that's 0.1 newton. So 2 squares on my y-axis is equal to 0.1 newton. Now, the first thing I have to plot is 0 and 1.7. Sorry, 0.7. So 0 along the x-axis, so I'm on this line here. So the point I'm about to plot is somewhere along this line. So it's 0.7. So I go up to 0.5, and then remember, 2 squares is 0.1 newton. So that's 0.6, and that's 0.7. So at this point, I put an X, and it's really important that you either put an X or a dot with a circle around it, so that the examiner knows exactly where your point is. Now the next point I have to plot is 1, and then 1.0 on the y-axis. So I go along to 1, my line lies along this point somewhere, and I go up to 1, and there's my point. The next point is going to be weight added of 2 and average friction of 1.3. So there's my weight added of 2. My point lies along this line somewhere, and I have to go up to 1.3. So I take a bit of a shortcut right up to 1, and then remember 2 squares is 0.1 Newton. So that's 1.1, 1.2, 1.3. And a bit like the scales, I can check I'm right and just keep counting to the next big number. So 1.4, yep, so I should have put that down there. So 1.4 and then 1.5. The next point is going to be 3 and then 1.6. So again, I can put my ruler on that line of 3 and I can take a shortcut up to 1.5, and then so there's 1.5, and then 2 squares brings me up to 1.6, and I put my X in. Next one, along to 4, and I'm plotting 1.8. So 4, shortcut up to 1.5, and then 1.6, 1.7, and 1.8. Put my X in, just check, 1.92, so I know I'm right. And the last one is 5 and right up to 2, so I can just shortcut the whole way up there. Okay, so now next thing and the last thing is I have to draw my line of best fit. So I have to make sure that my line goes through the stars. Okay, so a lot of the graphs that we have done so far have ended up starting at 0, 0. But if we draw a line that goes from 0, 0, you can see that actually that's not going to go through most of the stars. So that's not the line that's there. The line that we have got here goes somewhere around here. And the line that I have to draw has to go halfway between the points. So half the points have to lie above the line and half the points below the line. So if I maybe do my line about here, let's see what we've got. We've got 1, 2, 3, 4 points above and then 4 points below and then 2 points above the line. I maybe should have done that a wee bit lower, but still, I followed the sort of general trend, and there are some points above and some points below. Okay, last thing, my experiment has shown that, well, I have to write down about the variable that we changed, that as the added weight increased, and then what happened to the average friction? The average friction increased, and that is my conclusion, and that for first year is all I have to write. Okay, thanks girls.